Welcome, everybody. Today, we're here to talk about data modeling with Amazon DynamoDB. My name is Rob McCauley. I'm a specialist solutions architect at AWS. I've been in this role about 4 years, and I get to help large and small customers be successful on DynamoDB. I joined the company before this as a SQL developer. I really enjoyed learning about DynamoDB, the NoSQL single table access patterns, and I hope you'll share some of my enthusiasm. I'm joined by my colleague, Chad, as well.
Yeah, I'm Chad Tyndall. Thanks, Rob. I'm also a DynamoDB specialist solution architect, and I've also been here about 4 years. Previously, I worked at a few different other NoSQL companies, so I have some experience in this space and dealing with data modeling on these different NoSQL databases. Each one has its own little intricacies and nuances, and we're going to talk about some of the DynamoDB ones today. So I'm happy to be here.
Very good. All right, we have about an hour, and we're going to have a kind of a workshop format. We're going to do some slides, and then we'll do some live demos. And at the end, there'll be a link so you can download the same code and tables that we're showing you. All right, so with that, what is Amazon DynamoDB? I think of it as just an API in the cloud to do reads and writes. It's a purpose-built NoSQL database. We created it 11 years ago now. We released it on the cloud. And being serverless, it's kind of unique. You don't actually set up any infrastructure or have to make decisions about storage or CPUs or even networking if you don't want to. It's just an API. So it's super easy to get started. Also, we've taken pains over the last several years to move most all of our internal Amazon.com applications off of relational databases and into cloud databases like DynamoDB. So we really run the company on Dynamo. You'll see that anytime you use the AWS console, you'll know that DynamoDB is powering that screen and a lot more within Amazon. It's also built in to the cloud. So from day one, you get the IAM security. There's no separate security layer in your database. So it's super easy to deploy if you like serverless and you're building serverless applications. DynamoDB is the way to go. So what we'll chat about today is kind of how to think about DynamoDB, especially for all of us SQL developers. What's different about DynamoDB and unique about it? One of the things we'll be doing is planning our data model and understanding our access patterns. We have to do that earlier than usual because once we know our access patterns, we kind of know what to design and what to build. And we'll look at ways we can optimize our design. There's some tuning we can do to get a really good design that's going to be cost-effective and highly performant. And then we'll do a couple of demos showing how you might migrate existing data into DynamoDB and set up the model. And by the way, we're talking about data modeling, not any other type. All right, so Chad, tell me what you think about this analogy. So, we know relational databases are out there. I think of them like cars and trucks driving on the highways. They're very well known, can go anywhere, very flexible, but subject to traffic and unpredictable drive times. Compare that to the train network. Trains we know are really good for moving cargo across the country. They're also really good for city centers where there is a lot of traffic. And we know that they make sense in those scenarios, but it certainly takes some investment to decide where to build train tracks and also how to use them to put your cargo or your people on a schedule. But if you are okay with that, it's a great lower cost way to move stuff around. It can be 2 to 4 times more cost efficient than cars and trucks.
Yeah, I actually really like that analogy, though. In this case, I think the numbers are probably a lot bigger. If you have a well-modeled NoSQL schema, you're probably going to save a lot more than 2 to 4x in the long run.
Excellent. That's our goal today. And so there is certainly a learning curve. There's different patterns, I guess you could say, about DynamoDB to really leverage its awesome features and performance. There's no limit to how high you can scale up, both in size of tables and velocity. We can easily do tens of millions of requests per second. But with that, if you're bringing your legacy applications or your relational databases over to DynamoDB, I think of it as a golden opportunity to do some refactoring. Right? Maybe there's problems with your app already and you want to drop some features, maybe drop some historical data. Start over, start fresh in the cloud with the serverless pattern. With that, you can kind of document your access patterns and think about which ones are the most critical. If there's any highly patterns that need good latency, we can set that up in DynamoDB. And here's another interesting thing about DynamoDB. Very often we have this single table philosophy as a goal. And the idea here is to reduce the number of tables. So if you have 100 or 200 tables in your existing SQL database, it may not make sense to bring those over one for one into DynamoDB. We may decide to do one table or fewer tables and put together item collections and create these NoSQL patterns where we have everything in one place so we don't have to do joins. So when you start with DynamoDB, you're really going to create a table first. There's no infrastructure. You just go to the console and create a new empty table, kind of like creating an empty S3 bucket. You don't pay for any storage or configure storage. You just pay after you start using it and filling it up. The thing about these tables in DynamoDB is there's no real join operators. We don't have a full-blown SQL engine to perform joins or subqueries. So the access patterns are a little bit simpler. They're reads and writes, simple key value reads and writes, plus queries we can do, or scans. And the tables, like all database tables, need to have a primary key. So we would have certainly a partition key and optionally a sort key. What that means is we can have a single key value key, or we could have a two-part key, a composite key, that enables one-to-many patterns. Also, because it's NoSQL, there's no real schema. So once you've got your keys set, then it's up to you as a developer what you want to store. You can decide to store new fields or different fields anytime you like, as long as they have a unique key.
Yeah, I think that idea that the access patterns are simpler is key, no pun intended, because that's what allows us to achieve the massive flexibility and scalability that DynamoDB does have to offer, right? That's kind of the trade-off here.
Mm-hmm. Indeed. So when you create that new table, we name things slightly differently. The rows we call items. The columns we call attributes. Every table needs to have at least one attribute called a partition key. And that's going to help us decide where amongst our millions of disks we're going to store this for you. And if you want to have a sort key, then you can define that as well. And now you have the possibility to create one-to-many patterns. So if the partition key were customer ID, let's say customer 100, the sort key could be maybe an event timestamp. You could then do a query to say, get me all the events for a certain customer. And further, that sort key can be sliced and diced with range expressions. Get me all the events that are greater than 2023, or start with the word 2023-February, things like that. Chad, what about this? What's a global secondary index with DynamoDB?
Well, definitely we have different types of access patterns. So the way that we model data on the base table allows us to service some number of access patterns. But just like any other database where we want to be able to query on something other than the primary key, then we need to create indexes on other attributes so that we can service access patterns on those attributes.
Yeah, I think of it like a regrouping. So if your table is grouped by A1 and A2, maybe the customer plus event key, then if you wanted to look up by A4, look at this bottom index here. The GSI is a global secondary index. With these indexes in place that you can create on your table, then we have a regrouping, almost like a different structure or a different table inside your table. Now we can say, give me everything where A4 equals maybe a product name or name of an employee or something like that. So we can create as many of these GSIs as we like, up to 20 per table. And we can even tune them to be less than the full size of the table. We never write directly to the GSIs, do we, Chad? I think we always just write to the base table, and then very, very quickly those changes will be automatically synchronized and replicated into the GSI.
Yeah, again, I don't really think about this as being any different than any other database, right? Every database has indexes to service alternate access patterns, and every day, those indexes are maintained by the database engine itself. It's not something that the user has to maintain, and really GSIs are no different than that.
Yeah, that makes a lot of sense. All right, let's pop over to a quick demo, and let's take a look at a key value store. So here's a little visualization tool I have that will let us look at some data. And it's a simple table, customer contracts. Imagine these are maybe PDF contracts or some sort of key value pattern that you're trying to implement in DynamoDB. So PK means partition key, and this is just unique, as you can see. And then the rest of the field is up to you. In this particular case, we're storing some text. It can be up to 400 kilobytes. Whatever text you want to store is fine. And then the access pattern should be simply get item. You provide a key, and you get the value. Now, let's look at a slightly more robust version of this. Imagine we wanted to search on customer contracts. We can create other attributes besides just values. Let's try customer contacts version 2 now. So this one has been set up with a sort key. You can see that in the green here. And what we're doing here is versioning them. Imagine we are allowing updates to these values, and we want to keep the old version plus a new version. So what we have is now a one-to-many pattern. We could click on any one key, a partition key, and then see all the range of sort keys. And this is a great pattern for keeping a history. We can even do conditional writes. Try to make your changes and write version 5 if it doesn't yet exist. The system will allow us to do that or block us if it does exist. And then we can even do things like ranges. We're looking at V2, but maybe we want to get all the records that are greater than V2. So this is using a sort key range expression to get things greater than that, and there they are, V3 and 4. So it's a little bit like SQL where clause when you do these. All right, with that, let's jump into some modeling, especially modeling for your SQL schemas. How exactly would we bring over a simple schema of 4 tables? Should we bring them over one by one and just put them into DynamoDB? For sure, I think my first year, I thought that's exactly how you do it. And there's pros and cons of that for sure. But imagine what your existing relational database does. If you say, show me order 234, it goes to all of its tables, somehow magically assembles them all together, mixes and combines them with an inner join, and you get your one result. But if you bring 4 tables into DynamoDB, because we don't have a join, it's up to you as a developer to go in and assemble the data you need from all the sources. So probably you do a get item against the orders table, find order 234, then maybe try to get the customer information to enrich that result. Got it. Then look at the order lines for order 234. Oh, there's 2 of them. For each line, go ahead and look at the product ID and then turn around and come back to the products table and do get item for the products. So you can see we have like 4 or 5 or really any number of access patterns just to make the same view that we used to get from our relational database. So this is an anti-pattern. There's much more efficient ways to structure your data so you can avoid this.
Yeah, especially considering that this is a very simplified example. In a real world app, you might have hundreds or even thousands of different tables inside of your relational database. And so this idea really breaks down when you start talking about that type of scale.
That's right, yeah. Yeah, I always get nervous when customers say, we're going to bring over 100 tables into DynamoDB. That's when we have a chat about combining them into single tables.
Well, and also just talking about the fact that those 100 tables probably service a very large complex application, and really you should be modernizing your app and breaking it down into smaller microservices, maybe that each just have 1 or 2 tables, and peeling them off one at a time into whatever database is actually appropriate for that microservice, which may be DynamoDB, but it may be something else as well.
Could be something else, yeah. Could be for those key values, it might even be S3 if they're like large documents and you just want to put those into S3 instead of DynamoDB. You could still store the metadata in your table. All right, so if we don't want to bring over the tables as is, how exactly do we combine these tables? And we're looking at the left part of the screen here, and we're SQL developers. So let's see if we can use our existing SQL database, the relational database, to do the work to reshape the data and to combine them so that our migration into a single DynamoDB table is that much easier. And how do we, Chad, how do we combine data, in the SQL world? What are 2 ways?
Well, we can do a join.
Yeah, the join for sure. There's another one that's a little bit less common.
Like an aggregation query? I'm not sure where you're going with that.
Yeah, a union.
A union. Okay.
Yeah. Let's look at the join at least first. So here we have the central entity that orders and order lines together in one spot. And you can see on the left and the right, there's these kind of foreign key links here, cust1 and product 300. And if you just do a simple inner join against all these tables, you'll get one big wide result set. And it'll have some duplication though. It'll be more than the size of the original tables because look, customers is duplicated every time cust1 appears. Same thing for products. So but the advantage here is every single record is extremely complete. But if you do a get item for a single order, there it is. You don't have to hit the customers table. You don't have to go to the products table. It's all right there because it's essentially denormalized and we have what we need, almost like a cached version of the complete order. And this is great, by the way, if you want a low latency access pattern, get item for a single item is the fastest of all operations. How fast would that typically take in DynamoDB? Chad, do you think?
Oh, we're talking single digit milliseconds. I mean, 3 to 8 milliseconds at a P99 interval.
That's awesome. Probably better than the original SQL database we're doing.
Oh, yeah, definitely.
Yeah. And the advantage of DynamoDB, another great feature is that, you're not competing with other users. This isn't a big server with lots of applications taking memory and, churning through big complex queries. So this is a dedicated table, and get item, because of the indexing it uses, will have very predictable performance. Shouldn't expect it to slow down just because we're in a busy time of the day, for example. All right, the other approach now, instead of doing an inner join, if we do a union in our SQL world, we can shape the data by stacking it vertically like this. This is before we import to DynamoDB. And we can select from the first table some columns plus some nulls, select from the other tables, and make it all fit into one big result set. And the advantage here is we don't waste any space. So we have like a normal form still. We still have one version of customers, one version of products. We can't really do a get item for a complete item, but we can do some other neat things. We could do a query, show me all records for customer 2, including the customer details plus the orders that have that customer on them. And now we start to see the power of DynamoDB's item collections. This is like an item collection of its own, all grouped together on the same table. So the query will return in similar latency, very, very fast. We don't have to do 2 queries. It's all right there for us, just because of the way we've structured these different entities to line up on the index. Let's take a look at another example. What if we want to group by products? Maybe we're the product manager for the convertible car, and we've set up a GSI, a global secondary index, on the base table to group by product. We want to look up product 300 plus all the orders. We can do that by pointing to the GSI and making the similar query where partition key of the index is PR300, and there they all are. So that's a nice pattern as well. Depends on what's more important for you as a developer. Like, do you want to focus on the single get items, or do you want to focus on these more queries where you're getting a set of items across sets? I think of this as like a vertical join. They're all on the same table, but we've essentially combined them with a query. Let's go a little further now on this idea of stacking with union. So here's how you might create a SQL view before you've imported to DynamoDB. You just select those columns from table 1 plus null, select all the columns from other tables, put them together, they'll line up, and you can make a view out of that that'll look like as if it was a single table. And as we try to bring this into DynamoDB, we learned in the beginning that tables need to have a partition key and likely a sort key as well. So we know we need that. It has to be unique. We may or may not have that in our SQL data set. So let's go ahead and add 2 columns to the very beginning of this view, like so. And we can make some interesting decisions now about what we want to select for those keys. So here, what I've done is taken a customer first approach to the decision. So I'm going to put customer ID as the partition key for customers, orders, and order lines. And because of that, I can very quickly do a look across all records for any one customer. And the sort key now is maybe the word primary for the original customer record, but each order and order line could start with ORD number, and then now I can do a begins with. This is another operation on the sort key range. It begins with ord1, and that'll give me everything from orders and order lines that match that condition. But we could have picked anything for this partition key and sort key. What are some good guidelines, Chad, for choosing a partition key?
Well, I think the most important thing is to pick a partition key, that is a high cardinality, so it has a large number of distinct values. You don't want a partition key which just has a couple of things, like a Boolean would be the worst choice, or maybe an enum, which is a status, active and pending, just a few different distinct options, because you want to be able to spread this data across many, many servers on the back end as you scale up. So you need a wide key space to do that. So that's really the most important thing when you're picking a partition key. As long as you're picking one which is something that you want to query on, you should be good to go. So something like a customer ID or an order ID or something like that that has a large number of distinct values, that's usually a good choice.
Mm-hmm. And if we were creating an index, though, does the same guide apply? Creating a GSI that's going to have its own partition key?
Absolutely. I mean, GSIs really are just like tables. They're not that different from tables, except that they're maintained by the system. So you want to avoid low cardinality partition keys for GSIs as well, because that can lead to hotspots and ultimately, in the worst case, throttling. If the GSI itself doesn't have enough capacity because it can't be spread across enough servers, it can get throttled, and it will apply back pressure to the base table, and writes to the base table will start to get throttled eventually as well. So you want to make sure that both your table and your GSI are spread across a wide key space of partition keys.
Yep, that's awesome. What about the sort key? Is it the same or different guidelines for choosing a good sort key?
Well, choosing good sort key is really about, picking something that survives the access patterns that provides the access patterns that you need. So, the access patterns that you have are going to inform what your sort key choice is. The queries that you're running, does the result set need to be ordered by anything in particular? Like, does it need to be ordered by the date that an order happened, or the date that an order was last updated, or something like that is a sortable attribute? Then that's going to inform your sort key choice.
Yeah, I like that. I think the hint is in the name, sort key. It's sortable. It's alphabetically sorted, isn't it? So this item collection for cust1 is going to be sorted with primary first, and then O for the ords, and then each line will be in order. So yeah, things like this, where you have this sorting, or also dates are great format, year, month, and day. When that's in place, then you can do those range queries to get parts of a sort key range. All right, so let's see how we might set up some global secondary indexes. Hopefully we've gathered our access patterns for this table we're building, and maybe we find out we wanted to do lookups by sales rep. We haven't talked about that yet. It's certainly not part of the original base table's partition key or sort key. But if we were to store sales rep, in some other attribute in the table, and it was there in multiple entities, then now we can create a GSI on rep. Like we see here, GSI1. You can add this when you create the table or afterwards, and just simply group by rep. And now we have a really efficient, fast way to say, get me everything where sales rep equals Sam. And it'll do that across all the entities. We call it a global index because it's going globally across all the entities. And if you didn't have this in place, you would probably have to do something worse, like a full table scan. We do support this. There's a filter operation and a scan operation. So if you don't have your GSI in place and your table is relatively small, you still might go for a scan and then a filter. You could do the filtering yourself, I guess, if you bring back all the records, or we can do it server-side view as well. So that's
even if your table isn't relatively small, if your access pattern is run so infrequently, it might actually make economic decisions to say, well, this is just something that we need to do once a day for some sort of daily report. Maybe we don't want to incur the cost of maintaining a whole index just to service an access pattern that only gets run once a day. So for that one access pattern, we will do a table scan because it's just cheaper that way.
Oh, yeah, good point. Yeah. Yeah, I think so. Each GSI is going to add some overhead, right? Especially for write-heavy applications, they're going to increase the write costs. So you want to not add
and the storage costs, right? Because they have their own storage as well. So
as well. That's right.
it's just something that has to be looked at. Like, how often do I run this access pattern? Do I do it often enough to justify having an index just to service it? Right?
That's a great point. Let's take a look at another pattern for creating a different GSI. Now we are the product manager for the convertible car. We want to see your product details plus all the order lines where it's been sold. Maybe grouping by product and sorting by date. We can create another GSI that does that. Groups by product, partition key, sort key could be date. And that would be super easy to say, give me a report essentially of all the convertible cars that have been sold after February 1st.
Yeah, and sometimes you actually want multiple GSIs on the same partition key just so you can sort them in different ways. Like, you might want a GSI based on a product ID to see when cars were sold, but you might also want to see sorted by a different date, like when those orders were actually last updated. Right. So there's an order time and an updated time, and you might want to sort them on each depending on the access pattern.
That's right. Yeah. So we could imagine creating a third GSI that's sorting by a different date.
Yeah, exactly.
I think we could even do like a price. And the price is interesting because each product probably has a current list price, but it also might have a sale price. Maybe there was a discount and it got sold for different prices in the past.
Yeah, each order, right, you're not going to refer to the product entry from the order in order to get the price, because when you look up an order, you want to see the price that product was actually sold at for that order, which is probably different than the list price or the MSRP or whatever it is.
Yeah, so that price example, I think it's combining both denormalization and normalization, right? Because the normal form has the list price, but denormalized, it's got the actual price it was sold.
Yeah, so this idea of partial denormalization is quite common, right? We don't need to necessarily copy every attribute from the product row into the orders entry, but we might want to copy some of it to reflect changes that were made specific to that order.
And then if you had a GSI that groups by product and sorts by that price, it would be really interesting, wouldn't it, to say, like, show me the top 3 customers that had the greatest discount or paid the highest price, for example.
Yeah, you can find the best negotiator.
There you go. All kinds of options. All right, let's take a look at some date formats with DynamoDB. This is another part of modeling. Do we have a native date format in DynamoDB, Chad?
No date format in DynamoDB. It's the one data type that I think most databases have that DynamoDB does not. So you end up storing it either as a string, I say in ISO 8601 format, year, month, day, hours, minutes, seconds, or you can convert that into an epoch format, like the Unix timestamp, number of seconds or number of milliseconds since January 1st, 1970. Either way you do it, it's still sortable. So it still fulfills all the same purposes. And I think that's why the database never really added it, because it doesn't really solve any problems to have it, right? Just using a number gets you all the same things.
Yeah, I like that. So, stored as a string or a number. I think the key thing is to store it in hierarchical format so it sorts nicely. This ISO format is fantastic, isn't it? Year, month, day. It's almost like some developer made a hierarchy of like 3 separate fields, put them together with a delimiter. You can do the same all the way down to hours, minutes, and seconds.
Yeah, I see people migrating from a relational database sometimes where they have it stored in more of a human readable format, right? Month, day, year, kind of how we would write it in the United States. But when you do that, you lose the sortability order. You lose the ability to say, get me all the records between this time and that time, because like you said, that format is not hierarchical.
That would be a problem. Yep. We'd have to probably do a full table scan to.
You absolutely would have to do a scan, and so you end up changing the format back to something, one of these two options, when you migrate it into DynamoDB. But it's definitely something you have to think about.
Yeah, for sure. What about the number format? It looks like we could use that Unix timestamp. What would that give us?
Well, it's the same idea. It's still sortable. You can still do between queries. It's not human readable. So if you're looking at the data, if you're just looking at the data in the DynamoDB console or something like that, a human happens to be looking at it, there's no way they can tell what it actually means without running it through some conversion tool or something like that. But it's a little smaller, right? Storing a number takes up a fixed number of bytes, and it's smaller than the number of bytes that it would be storing, your third example there as a string. So some people just prefer the more compact format.
Yeah.
Those things can start to matter if you have hundreds of billions or trillions of records, which it's not happening in every single use case, but we certainly do have users of DynamoDB who have tables, a single table that has multiple trillions of records in it. And so adding a few hundred bytes here and there multiplied by a trillion records, it does add up.
Yeah. Yeah, maybe IoT use cases where you're tracking millions of events an hour. Well, one thing I like about this number format is we also have this cool feature called TTL, time to live. And the way this works is if you store a date in this Unix number format and it's a future date, you can tell the table, this is actually my expiration date for this item. And that's the TTL feature. Essentially, where you have a sweeper job that comes around every few hours, looks at your entire table, looks at these dates, decides, oh, is it expired now? If it has, it'll go ahead and delete that for you at no extra charge. And the reason I love this so much is it's a great way to keep your table from growing unbounded. It'll keep your records from growing forever. As they get deleted now, we have another service called DynamoDB Streams where you could still trigger and capture those and put those into S3 or our favorite archive, whatever we like. But normally, if you do a delete yourself, you first have to find the records you want to delete and then delete them. That's a write cost. So having TTL in place, if you can think about this on day one and designate a field for TTL and maybe put some value in there, maybe 5 years, we know that the record's not going to be valuable anymore. You can certainly delete it before then, but at least then it'll automatically drop off, which is a nice way to manage your table and growing. All right, with that, let's do our final set of demos. We're going to look at some more advanced modeling concepts. I think we'll also fire up the NoSQL Workbench and close off with a live demo showing how this tool works and how you can use it to build sample schemas and sample data and deploy it and test it. Okay, so here we have a set of tables we can take a look at in a region. We looked at the customer contracts one. Let's go ahead and look at some of these other ones. Demo table 2. This table, right away, this is the describe table telling us that it's got a PK and an SK as two key names. Let's scan the table, see what we get. Oh, interesting. Okay, so this tool organizes it into a grid. Keep in mind, DynamoDB being schemaless probably looks more like this because some values are null, some are there or not there. But in a nice grid format, we can easily spot where the nulls are. Sometimes we call these sparse. If a thing doesn't have a premium or a city, that's a sparse attribute.
Yeah, it's not so much
you
that
can
it's
also
null.
see that there's an item collection.
It's not so much that it's null. It's that attribute doesn't even exist in that row, right?
That's right. Yeah, it doesn't even exist. Yeah, there's no schema like with a SQL database where there's required columns or things, right? Yeah, if you wanted to store, a binary picture of your cat tomorrow, you could easily add that in. Now, some other things we can think about as designers and developers trying to optimize a good model is what are the size of these attributes? And this tool is coloring in this light peach color here. You can see that some of these attributes are rather large. They're 23 kilobytes, whereas the others are probably small, under 1 kilobyte. And the reason it's important to know about these is when you read them, or write them, we're going to take the full size of the item or the data that you're reading and writing and divide that by some capacity units and then calculate how much we're going to charge you in those units. So anytime you write a large item that's larger than 1 or 2 or 3 kilobytes, you know that you're paying a little bit extra depending on the size of the data that you're writing.
Right. Even if you're just updating one of the small attributes, you're going to incur the cost of rewriting the entire item, no matter how big it is.
That's a great point. Yeah, let's look at this one item here. Look how long, 23 kilobytes of text. Even if we just updated the rating to a new value, it's a small change, but you're going to pay 23 write capacity units to make that change. So that's perhaps an anti-pattern. One thing a couple of ways to get around that, I think, is to see if it's really big, like hundreds of kilobytes, you might just put it into S3 and not store it in DynamoDB. You could also perhaps create 2 flavors of this item, like order 003 is the sort key. But what if you had version A for the big payload and then version B for the metadata? These all share like a leading sort key, so it would be easy to get both if you want both, but it would also be certainly possible to update B, the small version, without touching version A, the large version, right?
Yeah, breaking up large items into maybe 2 or 3 different versions, even if it's just an A and a B version, which has the attributes which change frequently and the attributes that don't change frequently, that allows you to say, well, the attributes that change frequently, they're going to be in the item that's really small. So those frequent updates will be much cheaper because they don't have these larger attributes to rewrite every time.
Mm-hmm. That's a great point. All right, let's see what else we can learn about this table. What's this stuff here? 5 rows and 10 RCUs. What's an RCU, by the way?
Oh, it's a read capacity unit?
Read capacity unit. Yeah, there you go. So these are the charge for doing this read. I did a scan. It charging me 10 RCU. Each RCU is 4 kilobytes. And so I might assume that I have 40 kilobytes in my table, but actually you get a 50% discount so I think I have closer to 80 kilobytes. That seems to make sense. So yeah, the reads, depending on if you do an eventually consistent read or a strongly consistent read, we charge you full price, 1 RCU or half an RCU for every 4 KB that you read. And that's just true for a scan or a query or a get item. The other thing to think about is, what if we wanted to perform this query against customer 7, but then further, limit it to just balances that are greater than 800,000. So that's like a SQL where clause with a lot of different where statements. So we can easily do a query where PK is this customer 7. We may or may not decide to do the sort key range. But at that point, we have 5 items, 10 RCUs. If we want to get a filter going on balance or rating, we can do that. We simply tell DynamoDB, I also want a filter on this, everything that's greater than 800,000, please. And the server will knock out things that don't match the filter condition. But the important thing to keep in mind is you pay before the filter even starts. So we did find the 5 records. It did cost DynamoDB 10 RCUs, so that's the bill you'll get before you start doing your filtering. Now, I think for small item collections like this with 5 items, it's probably a fine strategy to use filters. But you want to be really cautious trying to do filters against a full table scan, or even against any item collection that's getting up into the hundreds or thousands of records per collection, because you'll always pay before the filter happens.
Yeah, but also even then, if you could get this 10 RCUs down to 1 RCU, and you're doing this 100,000 times a second, again, at scale, these things do add up. And so it is something to consider, optimizing for cost.
Optimizing for cost. Yep, exactly. Yep, another pattern too. We looked at this large 23 kilobyte payload. Imagine this was like maybe a JSON document and it has line items in there. We could perhaps even break that apart into a one-to-many, right? We can imagine a strategy where we're like, line 1 line 2, line 3. Each one could have a small piece of this giant text. And now we've created out of that giant value, we now have like line items, and then each one is small. It'd be easy to add another one or change any one without having to update the whole thing. Yeah. All right. Let's try another table, shall we? Let's try demo table 3, I think. This one has some GSIs, so it'll be interesting. All right, so I've scanned this table. It has 13 rows, 25 RCUs. Looks like it's got a payload. All the records have this 15 kilobyte payload. And it looks like there's just one item collection. So customer 753. It's maybe an anti-pattern if there's not high cardinality here. But let's assume that we're going to expect more unique partition keys as the table grows. Now let's take a look at the GSIs. This GSI is interesting. It's going to group differently. It's going to group by city and sort by this date field. So city is in purple and the date is in gold. So the tool will preview that for you. You can see that if the records don't have city at all, then they won't get to participate in the GSI. GSI will be that much smaller. And now if we wanted to click on any one city, we would simply request a GSI query now, and there's the result. So that's another interesting thing about DynamoDB is, there's no SQL optimizer. If you wanted to use an index, you don't just like hope the database will do that for you. You actually say, please point to GSI1. And with that, then you say the GSI partition key should be this word Philadelphia, and it'll go and do that for you. So you get to decide like what your access patterns are. You're not at the mercy of an optimizer that may make a good decision, or it may use some stale statistics and give you a poor access pattern.
Yeah, to be honest, this was always the advice given for other NoSQL databases as well that did have a query optimizer. For example, in MongoDB or DocumentDB, you have this hint operator that says, no, I don't want you to figure out which index to use. I'm going to tell you exactly which index to use because I built that index specifically to service this access pattern. So as the person writing the query, you know exactly which index you want used. That's why you put that index there in the first place.
Mm-hmm. That's a great point. Yeah. Let's you can also scan an index just like a table if you want to do that. And let's look at the colors here. This tool is like showing in purple and yellow the partition key and sort key of the index. But also here in blue and green is the original primary key of the base table. And the reason this is interesting is if you wanted to do a get item, there is no get item on a GSI at all. You can only do queries, right? Because they may not be unique against the GSI sort key. But if you see the original base table's partition key and sort key, those of course will be unique. And by using that, we can go back to the base table and see the one unique record that we might want to look at. All right, let's look at the other GSI on this table. This one here, it looks like it's also sparse. This one happens to be grouping by product. And this one, why is this sparse? It's got a product. I'm not sure why it didn't join the GSI. Oh, it doesn't have a sort key. Okay, so it is sparse because both of the GSI's keys don't exist. So it's not really able to join the GSI. So these sparse patterns are great because the size of the GSI will be less than 100% the size of the base table, which is less storage to pay for. Also, if you happen to update this one record here that's hidden, the second record that's not in the GSI, if you just change its rating, it won't incur any extra cost for updating the GSI because it's not in the GSI. So we oftentimes use this sparse pattern. We create nulls or missing values because we know they're probably not going to be needed by anyone reading the GSI. They're not adding value. Let's make them null or leave them out, and the GSI can be that much smaller.
Yeah, and if you do a real needle in the haystack type use case, it allows you to just do table scans on the GSI because there's only going to be a few rows in it or a few hundred rows in it anyway.
Mm-hmm. That's right. Yeah, look at the premium column. Those are a needle in a haystack. It'd be interesting to create a GSI just on this premium. They're really sparse. It'd be a tiny GSI.
Yeah, we've seen things like.
All right, let's go back and look at I think demo table. Yeah, let's take a look at demo table 7 here. This one's got 3 GSIs. Yeah, and there's the premium one again. Yeah, needle in a haystack, right? If you wanted to just get certain values that are extremely rare, you can create a low-cost GSI and just pull those out, almost like a pre-built report. Here's an interesting thing now. As a designer, I think it helps you to keep in mind what are the average item collection sizes. Right, this tool has a way to like summarize that. Well, there's 2 collections in here, and the first one has an item has a count of 7. The next one has an item count of 4. These are pretty small. I would be fine to filter against them. But be careful these don't grow unbounded themselves. If this is like a medical record for a certain patient, and they have 7 medical history records, but as the years go by, they start to get hundreds and hundreds of records in the collection, suddenly that filter that you were doing is going to be more and more expensive because the item collection will be growing. So if you do a query plus a filter, we want to have a sense for how expensive that might be. Now we can always estimate that by just doing a regular query without a filter, right? We know that whether we filter this or not, it's going to charge us 5 RCUs to perform this query. So by the way this number is coming back, you can get it yourself. Anytime you do a DynamoDB operation, you can set a flag called return consumed capacity, and that'll give you some metadata from your read or write, telling you exactly how expensive it was in the capacity units. So it's a great way to profile, an access pattern where you're not sure if it's going to perform well or if it's going to perform cost effectively. You can see exactly how much it'll charge you. All right, this one has similar. Oh, what's this? This one has a GSI that looks not just sparse, but there's some attributes missing. What's going on here, Chad?
Oh, you've done a projection in the index. Is that what's happening here?
Yeah, it looks like the index is super small. It's grouping by car, sorting by status, but look, this 5 kilobyte payload and a few other things don't participate in the index.
Yeah, so you have this option when you define what an index is going to be. You have the option of saying which attributes from the base table actually get copied into the index so that you can make the items in the index smaller than they are in the base table by omitting certain large attributes. If you don't need them to service the access pattern, which the index is there to service in the first place, you could just leave them out of the index entirely.
That's awesome. Yeah, we're leaving out 5 kilobytes of payload. It's pretty small. Now we could, if we wanted to get the total rating or the average rating, because we've made this super small and compact GSI, we can imagine getting hundreds or thousands of records from it without a lot of expense, and then maybe doing a little bit of light aggregation on our own because we're able to pull back thousands of records at low cost because of the sparse GSI and the minimally projected GSI. So that's nice. And by the way, the counts here are not showing up. See where my mouse is. If you wait a few hours, DynamoDB will go in and size all your tables. I just happened to load these up before we started, but generally, if you do a describe table or look in the console, you can see exactly how big your GSIs are or your tables are, and you can get a sense if they're sparse. Maybe the base table is 5 gigabytes, but the GSI is only 1 gigabyte. That would be a clue that you're using a couple of these patterns to make the GSI size smaller. All right, here's a final interesting GSI. So you can see in purple, we're grouping by the partition key and sorting by the balance. And we're leaving off some attributes that we don't want the big attributes in there. And this is a pattern almost like another type of index we have called an LSI. Chad, what's that, an LSI?
Local secondary index. So this is a special type of index which is actually stored not in a separate copy of the table, kind of like the way the GSI is, but it's actually stored inside or alongside the physical storage of the base table itself. And because it's stored inside of the base table itself, it can be updated under the same lock that is used when you change the base table row, which means that LSIs themselves are strongly consistent, unlike GSIs, which get replicated from the base table in an eventually consistent fashion. So it does have some downsides to it. It causes some changes to be made on the DynamoDB side in terms of how much data can be stored for a given partition key, for example. It also has some other effects on the way that we split partitions and things like that. So we generally don't recommend customers to use it because it's just not as flexible as a GSI. Right? It can only be defined when the table is created. You can't add and remove them later the way you can with the GSI. So GSIs tend to be far more flexible, and for that reason, that's usually what we recommend to most people. But every once in a while, there's a use case where you absolutely need that strong consistency, and you're willing to take the inflexibility that the LSI gives you in order to get it.
It's very interesting. Yeah, I'm not a fan of the LSIs either. I created this GSI to look and behave like an LSI, just to show that you can do that, and you could drop this or recreate it, which you couldn't do with an LSI. So yeah, grouping by the same thing, sorting by something different. I think this pattern is useful when you have those large item collections. If this was an item collection of 1,000, and it was super critical to get the top 3 by original sort key, also we need top 3 by balance. Those would be pretty hard to do unless you had these different sorting structures set up through a GSI or perhaps an LSI. All right, good stuff. Well, we have a few minutes left. Should we take a whirl in the NoSQL Workbench for DynamoDB? So if you haven't used it, yeah, let's do it. It's a great tool. It's a free tool. You can find, just search for NoSQL Workbench. You can download it and put it on your laptop, put it on your home laptop if you like, and just hack around, create some data models. It's got 3 main features. There's a modeler, there's a visualizer, and there's an operation builder. So the modeler sort of lets you create tables and indexes and start to add sample data into them. Visualizer really shows what's happening, just like the other tool we saw. So it'll show you the one-to-manys, it'll show you the regroupings that an index creates. And then the operation builder will let you actually connect to your live cloud and push the table into your dev account if you like, or do some light administration of your table. Plus my favorite feature, Chad, is the code builder. You can actually generate pages of code with this tool as well. Let's create a new data model, shall we? Let's do it from scratch. My supermodel. All right, so the model itself is just a concept, but really we want to add 1 or more tables to the model. Let's click an orders table. And the partition key, we can choose any name we like. It doesn't really matter to the system, but because we often overload this with different types of records, I like to have something pretty generic like PK. Chad, should we make a sort key?
Yeah, I definitely think we should make a sort key.
All right, let's do it. SK, generic as well. Now, in DynamoDB, you could stop there and just push this table and make it live and start using it, because all the other attributes can be defined by whoever's writing the records. But this particular modeling tool is going to want to render a big grid with your attributes. So we do have to give it some hints, like what other attributes are going to be in this model. So let's go ahead and do that. Let's create something. This is the ones we saw, like product. It's a string, maybe date, maybe city, things like that. All right, and we won't create GSIs yet. We can do that as a second step. Let's go ahead and add that table definition. And there it is. Doesn't mean too much yet, but let's put some data into it and see what happens. I'm going to click Visualize Data Model. Click on the table here in the middle. and then click on this little update blue link here, and that's going to open up the grid so I can start adding some sample data to see how this works. So let's say add PK could be cust 100. Sort key, maybe this is a date for an event, like a sale or something, 202303-01. Product can be car. Date, I'm going to duplicate the date here. And by the way, this is something we often do in DynamoDB, is feel free to take a few extra storage bytes if you need a duplicate of your key, because we want to have date standalone for an index to find it and use it. We can easily just duplicate that as well. And the city. Let's add a city and then add another row. Same customer. 3-02. Next day, they bought a bike. I'm going to put in the next date, and they bought a bike in New York. All right, let's add a third row. Now, this is going to be cust 200, and they should be on the same date. It's fine. And they also bought a bike on that date, and they bought a bike in, I don't know, Philadelphia. All right, that's, I think, all we need to show some of the modeling in action. I click Save. Now we have a grid view. We could easily click Aggregate View and start to see the one-to-many. Right, and you probably have seen this if you've studied DynamoDB. These kinds of screenshots appear in a lot of documentations and blog posts. And you can certainly capture them yourself, put them on your wiki, explain to your dev team, like, this is the structure for our records. All dates should look like this, and so forth. But let's see if we want to group.
You're going to create a GSI now by product type or by city or something?
Yeah, so we do that, I think, by product type. Let's go back to the modeler and edit the model. Add a GSI, GSI1. Maybe just group by product. Yep, and maybe not even a sort key. Save edits. Now we can come back and visualize this model. And look, there's another tab on the top here. We can click on the GSI view, and boom, it's grouping by product now across all customer records. So that's pretty nice. It's another access pattern we can support and support efficiently, even for a huge table. All right, if I like it, I can press this button to push it into my real dev account. We can also take a quick look at Operation Builder here. Let's open up this and see some of our existing records. Existing tables that we created earlier. So here's the demo table 2. It's a live scan. There's the data. Maybe I want to do a query for cust for the same table for the cust -0007. Let's run that. Success. There's the 5 records. All right, here's the awesomest part of this tool chat is the generate code. And what's the best language should we develop in? What's your favorite language? It has to be Python, JavaScript, or Java.
Yeah, no JS for sure.
I agree. That's a good one. So look,
I go back and forth between that and Python, to be honest.
Python's good too. Yeah, I think so. But the beautiful thing about this is we use our mouse to do this. There's a little bit of formatting that it does for us. You don't have to read the docs to get this query going. It's also got a nice section at the end of at least common error handling exceptions that may happen. And you can put custom handlers for each of those. Like if you had a syntax error, table not found, or throttling exceptions, you can have logic to handle those. So that's the final exercise for you, viewer, is to copy this, put it into a Node.js text file and run it. And if you want to try it out, the only thing I'll tell you is this line 60, handle query output. You want to like put a console log in here and just show the query output so that we can see what the results of the query are. All right, with that, we are almost out of time. Just to recap what we learned today, we learned a lot about DynamoDB and modeling. We learned it can support different access patterns like key value. It can support relational data. And important to document your access patterns. Think about the exact reads and writes that your application needs so that you know what to build in your table. We learned how to use this NoSQL Workbench tool to create a data model, test it out with sample data, and deploy it. And we also learned a new way of thinking about tables, the single table design philosophy. We're stacking multiple entities into a single table so that GSIs and item collections will emerge. With that, me and Chad would like to thank you for your time today. Hope you've learned some new things. We'd love to see you on Twitter or shoot us an email if you have any questions. And here's a QR code that will link you to the sample data and NoSQL Workbench model with all 5 tables that you can grab and try yourself. Thanks for your attention. We'll see you next time.
Yep, thanks, everybody.